Okay, so as I said, we're starting a new unit today, but we're still dealing with these three-dimensional shapes. So we're not moving away yet from prisms and cones and cylinders and pyramids and all of that stuff. But what we're going to do now is switch gears a little bit and talk about volume. Can you guys, anyone out there, tell me in your own words, what is volume? How does it different than what we were doing with area, maybe? Brady?
The space inside something.
The space inside something. Surface area was the space outside, like what I need for the material to create the shape. Okay, so like think about a cylinder. When they're making this canister up here, they have to think about how much plastic do I need for the lid and the bottom and the wall of the cylinder. Okay, but volume would be how many of the Clorox wipes can they fit inside of here? How much space does this have? Or think about like a pool. How much water can you fill into your pool? Or how much air can you pump into a sphere, a basketball or something like that. So we'll start talking about volume now in the space inside of a shape. Some of the things that we talked about from the last couple of units, even 2 units ago, when we were just dealing with regular area or like our special right triangles, or even some like trig might show up, like sine, cosine, tangent. Some of those things might still creep their way in as we're still talking about volume. So when we think about a prism, because that's the shape we're going to start with, we started with a prism for surface area as well, you have to make sure that you can identify your base shape. And we talked about this on that bell ringer, but remember your bases are always the two shapes that look exactly alike, and they're always parallel to each other. So if you're looking at a prism and you're confused on what's the base versus what's the faces of it, make sure you're asking yourself those two questions. Are my bases the same shape, and are they parallel to each other? Because if you have to say no to either of those questions, then you're not looking at the right part of your shape as your base. So even on my pictures up here, they're again kind of highlighting for you what the bases would be. You should hopefully be able to see on all 3 of those examples up there that the triangles are parallel to each other, that the rectangles are parallel to each other, the hexagons are parallel to each other. They're never going to cross. So that's why they would be my bases. Now, volume of a prism has a formula that we can use, and that formula looks like this. It's a capital B times a small h. Any ideas what those might represent?
Base times height.
Good. Base times height. I'm going to elaborate on the base part a little bit, but I'm good with the height. So let's say h is height. The reason why I said I want to elaborate on what you said with the base is this is a capital B. In all those formulas that I have written over there on the board, all those area formulas, do we have a capital B anywhere? No, all of those had little b when we talked about like the base of a triangle or the base of a rectangle. My formula now has a capital B in it, so I'm still talking about the base shape, but I'm not talking about just the base length. So capital B represents the area of your base shape. So it's a little different. When we're working with a prism, the first thing we're going to want to do is figure out what's my base, because that's going to be the majority of my work. Finding what we would plug in for capital B is going to be the majority of the work, because that's going to be looking at your base shape individually and figuring out, is it a triangle? Is it a trapezoid? Is it just a rectangle? How do I find area of just that shape? And then H is going to be the height of the prism. Now look at all of these pictures up here. On these pictures it says height, height, height. On all 3 of them, the height is the space between your bases. So when you're looking at a prism, especially because some of our formulas are also going to have H's in them for our base shape, you want to make sure you can differentiate, is this the height of my base shape or is this the height of my prism? Because we can't just pick whatever number we want. There's a point and reason for each of them to show up. So if I was working with this last one with these hexagons, I would need to find the area of just this hexagon first, and then for my height, I would need to figure out how far apart are those hexagons. How far apart are they spaced on my prism? Okay, so we'll really want to be careful when we're identifying some of these pieces that we're just being extra cautious that we're not grabbing the wrong number. So let's get into some examples here, starting with this first one. How would you name that? It's a rectangular prism. So remember, the name of the shape includes the base in it. That means that it has a rectangle for its base. Now, mine has it kind of highlighted here. So they're saying that the front of the shape would probably be your base, okay? But on a rectangular prism, this is one of those shapes where we talked about in the last unit, it doesn't really matter what side you use as your base when it's a rectangle, because all of them are rectangles. It changes when your base shape starts to change to something other than a rectangle. But in this case, I'm going to use that they have highlighted up here as my base. Now, notice how underneath this, where it says base, and then it says to draw it. This is kind of like your net idea. Let's isolate our thinking right now to just the base shape so we can fill in part of our volume formula. So I'm going to draw out just the base, just that rectangle that they have shaded in for me. What are the dimensions of my rectangle? 6 and 20. So I'm going to go ahead and put that on here. Now I'm dealing with just a rectangle right now. How do I find area of just a rectangle? Base times height. Now again, notice we're going back to little b, and I have a height in here, so we have to be careful that we're using the right numbers. I'm only looking at the rectangle right now. What would be my base and my height of my rectangle? Careful. Just the shape. How would you find the area of just the shape? You have the number, but how'd you get it? 20 times 6. So that would be the 120 that you gave me, right? That's just part of my volume formula. My volume formula that I wrote up above said it was the area of the base times the height. And that's what you had said, right? You said 120 times 14. Why is he using 14 and not 6? Is it right to use 14? Yeah? Why is it 14 and not 6? Where are the base shapes? Front and back. So the front is a base, and this back rectangle here is a base. You're looking at how far apart are they? According to the picture, they're 14 centimeters apart. That's why we want to use 14 right now and not the 6 again. So that's why I said you have to be careful with identifying your height, because this formula had a height in it when we went back to just our 2D shape. Now we're back to our three-dimensional shape. It has another H in it. So it can be confusing at times, especially as you're getting started, to understand what does that H represent in my picture. When we're back to volume, we're back to the prism and how far apart your bases are. So what is 120 times 14? 1680. And do you guys know how to label volume? Area was centimeters squared. Volume's a little different. It's cubed. Very good. Centimeters cubed. So make sure you're making that transition to having a 3 as your exponent instead of a 2. Okay? Do we have questions on that first one? Okay, let's move on to number 2. First thing I always do is I name the shape because it helps me identify where my bases are. How would you name this prism? Triangular prism. This one's different than the last one. It's no longer rectangular because they have it highlighted on my screen here, but these are triangles. So that's going to change your base shape. So I'm going to start by drawing out my triangle. Down below here. Just going to draw that out. Do we know any of the dimensions on just the triangle? Okay. Okay. We know the long side is 12. How do we know that? Yeah, we've talked in class about those Pythagorean triples, and I had said 5, 12, 13 is one of them, and it shows up a lot in this class. It's just built into a lot of the shapes that we're going to work with. But there are other Pythagorean triples out there, like 3, 4, and 5 make another one. 6, 8, and 10 is another one that you might see a lot. But this is one of those that showed up, and we've talked about it in the past. Now, if you don't know that, if that's like, you don't remember us talking about that in class, you can still use a squared plus b squared equals c squared to figure that out. You would just do 5 squared plus b squared equals 13 squared, and you would still get 12. Now, I needed that 12 because my shape here is a triangle, and how do I find area of just a triangle? Base times height divided by 2. Is the 13 helpful to me at all when finding area of this triangle? No, because it's the slanted hypotenuse side. We don't use slanted sides when we're trying to find area. Okay, so I want to use 5 and 12 as my base and my height. So I'm going to do that. We're going to put in 5 and 12 for the base and the height of my triangle, and you're going to divide it by 2. What is that? 30. Again, that's just the triangle. I'm now going back to my 3D shape because I want to find volume. Remember, volume is still area of the base times the height. We just found area of the base. We said it was 30. H now is talking about the height of the prism. How far apart are those triangles in the picture? 15 centimeters. Along the top there, you're thinking of how far from this triangle to this one in the back are they? It's 15. Don't use this as your height. That's not the height of the prism. That's the height of the triangle. So we got to use that 15. What's 30 times 15? 450. And still label would be? Good. Centimeters cubed. Very good. Okay, that one was a little bit different because our base changed to a triangle. Do we have questions on that one? All right, let's go on to the next one, number 3. What shape's your base here? Hexagon, because this would be a hexagonal prism. So down below, let's draw out the hexagon. What do you know about the hexagon?
All the sides are 6.
All the sides are 6. So I'm going to just put down here, this is 6 all the way across. All right. How do we find area? Because I just want to find the area of this. This is my base shape. How do we find area of a hexagon? What's the formula that we use? It's still on the board over there if you don't remember. Which one do we use for a hexagon? Good. Apothem times perimeter divided by 2. Okay. Could I find the perimeter of my hexagon? Yeah? Because how many sides does it have? 6, and they're each 6. So 6 times 6 would be 36. So I could put that in for my P. Do I know the apothem length? No. Where's the apothem at again? From the center, where do I go to say it's the apothem? Middle of the side. So I go straight down. Okay, remember this one that we would also need to maybe draw in is called the radius of the shape. Okay, but this is what I need. This is my apothem, and I'm missing that. Okay, so we got to do a little bit of work here, and I'm going to make you kind of stretch your brain a little bit. You got to pull back some stuff from a couple of units ago. How much is a full angle on a hexagon? 120. Okay, that's an entire angle. Each corner is 120. So when I drew in this radius here, what does that do here? Cuts it in half, so it's 60 now. So this angle on the triangle is 60, which means this one would have to be 30, and this is where my right triangle would be. So we're back to a 30, 60, 90 triangle. Now, do we have anything that we could fill in on this triangle to maybe help me along? 3 on the bottom here, because that's half of it. It's halfway across that side, so that would be 3. So maybe let's think through this here now. I still have those right triangles up there on my board too. What side is always across from the 30 degrees? S. So this 3 is your S side. I need the apothem side. What is that across from? 60. And 60 is always represented by what? Good. S square root of 3. So if my S is 3, what would be my apothem length? 3 square root of 3. I needed to find that so that I can plug it back up in here to my formula. So now we're going to go back up here. 3 square root of 3 goes in for your little a. All right, so let's go ahead and do this, and let's not work with the square root of 3 right now. Let's just leave that attached to my answer. So let's take 3 times 36 and divide by 2. What does that leave me with? 54, and then I would still just need to have square root of 3 attached. Okay, just like pi, I'm gonna continue to not work with those things if I can help it. So I would leave pi in my answer. I'm gonna leave square root of 3 in my answer. All right, we are almost done, but we're not completely done. Now, honestly, the hard part's over. Okay, this is what's gonna take up the most of your work, finding the area of the base, especially when you start to get into these really weird shapes. So this one is your base, your area of your base, but now I need to go back to volume. Volume said area of the base times height. Well, we just found the area of the base to be 54 square root of 3. What's the height of my prism? 10. Again, you're thinking, how far apart are those hexagons? 10. So what's my volume?
540.
Very good. Okay, that one was tougher than I think the first two were. Do we have any questions on that one? Anything I need to clarify for you really quick? This part is brand new. This part is not brand new. We did all of this before, so it is a lot of retrieving and pulling back from previous lessons and trying to keep track of all those things. But I would just suggest when you're working with these prisms, start with that base shape first, then work your way back to your volume formula. Once you find B, like I said, honestly, that's the hardest part of all these problems, to find the area of your base. Once you're done with area of the base, then it's just taking it times the height. That should be the easy part of finding volume. Okay, we've got one more. What's going on here with number 4? Could we name this a rectangular prism?
Yes.
What side do you think is the base for this one?
The front side.
The front side? Kind of like this almost L-looking shape?
Yeah.
So is this a true rectangle? No. So there's really not like a great way to name this because they kind of gave me a really odd shape as my base. Okay, but I might be able to break it apart into rectangles. Okay, but that front is your base shape. So I'm going to draw that out first here. Okay, and let's start labeling it. Do we know how much the far left side is? 6. How about the bottom?
4.
And it has 2 dashes, and this side has 2 dashes, which means it's also 4. Okay, this little lip up here is 2, and this side has the same arc, so it's also 2. How long is the top?
6.
Also 6, right? Because it's 4 from the bottom here, plus this 2. So this side is also going to be 6. All right, let's isolate just to our base here. How could I, or how would you cut this up so that it's easier for you to work with?
Make like 2 and 2 like a little box.
Okay, like that. So that little 2 by 2, that's a square now. And then this other shape is still a rectangle. We can find the area of those individually. How would we find the area of the rectangle? Base times height, 6 times 4, which is 24. Okay, this one, the square, how would we find area of that? 2 times 2, which is 4. Okay, so for my total base area, so for my capital B and my volume formula, I need to add those two smaller amounts together, 24 plus another 4. So that's just 28. Okay, what do I need to do, though, to finish this off? Solve for volume. So I did the hard part. I found the area of the base, which we said was 28. How far apart are the bases? 10. So from the front, if we're saying the front's my base, to the back should be 10. So we're going to take 28 times 10, which is how much? 280. And what's my label? Good, centimeters cubed. Questions on that last one? Okay, I'm going to get you guys your homework here.